Okay, for topic 3, we're still talking about probability involving or. Okay, so we're still dealing with events involving or. But now we need to talk about non-mutually exclusive events. It's very, very important that you understand the difference between mutually exclusive and then non-mutually exclusive. So as a kind of a reminder, mutually exclusive means it is impossible for events A and B to occur simultaneously. They can never happen at the same time. It can never be negative 1,000 degrees and then 500 degrees at the same time. It's either or, okay? You can never roll a die and land on a 4 and a 5 at the same time. You either land on a 4 or you land on a 5. Drawing from a deck of cards, you either have a 10 or you have a face card. There's no card that is a mishmash of 10 and a face card. It's either a 10 or it's a face card, okay? When it comes to non-mutually exclusive events, it's a little bit different. So, as a definition, if events A and B could happen simultaneously, then the events are not mutually exclusive. So when we're dealing with non-mutually exclusive, it means they could happen at the same time, okay? So we do have a formula that we need to know about. It says if events A and B are not mutually exclusive, okay, that means they could happen at the same time. Then if we have the probability of A or B, we would still take the probability of A. We would take the probability of B, but the issue is there's going to be overlap. So we have to subtract off the probability that both things happen at the same time. So I think of this as the overlap. Okay, so imagine, well, we'll look at different scenarios here, but imagine a situation where something could happen at the same time. Okay, you can't count it twice. So when you're adding the probability of A and you're adding the probability of B, if there's something that could happen in A and B, you don't want to count it in there in both sets. So you got to take out the overlap. Okay, so let's look at some examples. So find the probability again until I tell you otherwise. We're going to assume that we want reduced fractions as our final answers. And that is, like I've said this many times, that's typically the case with theoretical probability. We tend towards the reduced fractions, okay? So for part A, it says you roll a fair six-sided die. What is the probability of rolling a 1 or an odd number? So the thing here is 1 all by itself, but 1 is also odd. So if we're looking at the probability of a 1 or an odd, we would get the probability of a 1 plus the probability of an odd, but because 1 is also odd, it's being counted here and here. We can't have that. So what we have to do is we have to subtract the overlap. Okay, and this is probably going to make more sense with decks of cards than it is with rolling a die. But all the same, let's get to it. So we know the sample space for rolling a die is 6. Okay, we have 6 sides to a die. One side has a 1 dot, another has a 2 dots, then 3 dots, 4 dots, 5 dots, 6 dots. Okay, so the probability of rolling a 1 is just 1/6. The probability of rolling an odd number. Well, we have 1, 2, 3, 4, 5, and 6. Of those options, 1, 3, and 5 are odd. So 3 out of 6 are odd. But we have to subtract the overlap. So of the odd sides, how many of them are also just a 1? Well, 1. So we want to subtract the overlap. And so what I end up with is 1 plus 3 minus 1 over 6. Well, that ends up just being 3 over 6 or 1/2. Okay, so again, you have to subtract off any overlap where the two events can occur at the same time. Okay, part B, it says you are dealt a card from a standard 52 card deck. What is the probability of being dealt a 2 or a heart? These can occur at the same time. You have your 4 twos, you have your 13 hearts, but of those hearts, one of them happens to also be a 2. So we have to add the two probabilities and subtract some overlap. So let's see what this is going to look like. We have the probability of a 2 or a heart. So that means I want the probability that I draw a 2 plus the probability that I draw a heart. But remember, we have a card that is a 2 and a heart. So we can't count it in the 2s and the hearts. It can only get counted once. So we need to subtract the overlap, which happens to be the two of hearts. So the two of hearts is being counted here and here. It can't be counted twice. It can only be counted once. So we have to subtract off that second time it was counted. Okay? So with a deck of cards, we have a denominator of 52. So we're going to have three fractions that have a denominator of 52 because there's 52 cards in a deck. Okay? How many of those cards are two? Well, or how many of those cards are twos, I should say. We have 4 twos in a deck. How many cards are hearts? Well, 13 of them. But how many cards are twos and hearts? Just one. We have the 2 of hearts. So we have to subtract off that overlap because that 2 of hearts is being counted here and here, and it can only be counted once. Okay? So this means I'm going to get 4 plus 13 minus 1 over 52. Well, 4 plus 13 is 17. 17 minus 1 is 16. 16 and 52 are both divisible by 4. So we get 4/13. So if you were to draw a card from a deck, the probability of getting a 2 or a heart where we take out the overlap would be 4/13. All right, let's look at another one. So a deck of cards again. Part C, you are dealt a card from a standard 52 card deck. What is the probability of drawing a jack or a red card? So we know we have 4 jacks. We have 26 red cards, but there are red cards that are also jacks, okay? So let's see, we want the probability of a jack or a red card. And I haven't mentioned it, but notice we still have the word or. So when we're dealing with these or probabilities, it's kind of obvious because you're going to see this or that, okay? So let's see. We have the probability of a jack or a red card, okay? So we want the probability of a jack plus the probability that we have a red card, but we have to subtract off overlap. There are cards that are red and jacks, okay? So we want to subtract the overlap. Well, again, we're dealing with a deck of cards, so we're going to have something out of 52 plus something out of 52 minus something out of 52 because we're subtracting the overlap, okay? So how many cards are jacks? Well, in a deck of cards, 4 are jacks. 26 are red, but of those red cards, some of those cards are also jacks. We have the jack of hearts and we have the jack of diamonds. And that's being counted in both the jacks and the red cards. So we have to subtract that overlap out. So we want to subtract the 2 cards that are being counted twice. Okay? So that means I would get 4 plus 26. Whoops, I just about didn't add. Minus 2 over 52. So let's see, 4 plus 26 is 30. 30 minus 2 is 28. So I get 28 out of 52. Both are divisible by 4. So I get 7/13. So the probability that you draw a card from a deck and it's either a jack or a red card, minus the overlap, would be 7/13. Okay? Did I say 32? I feel like I said 32 at some point. It's 7/13. All right, part D. At a school, 60 students were surveyed about their schedule. Of the students, 45 are taking math, 30 are taking English, and 20 are taking both. That makes sense. Right now, I've probably got students that are clearly in a math class, but you might also be in an English class. That's completely reasonable. You could have both, okay? There could definitely be overlap. All right, so if we want to find the probability, so if we select one student from the group, what is the probability? Let's see, if one student from the group is selected, what is the probability that the student is taking math or English? So we want the probability of math or English. So that would be the probability that we have a math student plus the probability of English. But there's definitely overlap. We have to subtract the overlap. We can't have students counting in both groups, okay? So we want to subtract the overlap. So let's see, how many students were we dealing with? We had 60. So we're going to have fractions involving 60 as the denominator. So first we have the probability that we choose a math student. Well, 45 of the students are taking math. 30 are taking English, but 20 are taking both. So we have to subtract the overlap. You can't be counted in both groups. You can't be counted in math and English because that's going to throw off our probability. We have to subtract the overlap. So let's see. That's 45 plus 30 minus 20 over 60. So let's see, 45 plus 30 is 75, minus 20 is 55. And if we divide these both by 5, we get 11/12. All right. So if you were to randomly select a student from this group of students, there's an 11 and 12 chance that you're going to get somebody that's in either math or English. Excuse me. I think that might be, yeah, that's it for this one. So the big thing for the last two videos, this video and then the one prior, we're dealing with or probabilities. What is the probability of this or that? Okay, that's easy enough to understand, but two different situations can occur. You can have a situation where your events are mutually exclusive, meaning they could never happen at the same time. You just add your probabilities and move on. Then you can have the situation where events could occur at the same time. And if that is the case, you add the individual probabilities, but you must subtract off the overlap because you can't have something that's counted in two groups. It can be counted in one or the other, but you can't count it in both. So if something could occur in both groups, you add the two probabilities and then subtract off that overlap, and that takes care of everything. So when events can occur at the same time, we say they're non-mutually exclusive or not mutually exclusive, and you add the probabilities and then subtract the overlap. Okay. In the next video, I think it said we're going to deal with empirical probability. So we're going to be dealing with the or stuff, but now we're going to be looking at real values from a table.